Hi, hello everyone.
Hola, hola.
There's a lot of people from Latin America, so.
We will speak in Spanish. Yeah.
Don't worry. It's joking. Well, my name is Claudio Caracciolo, and I am from Argentina. With me is Sheila Berta, is from Argentina too. Both working in Telefónica in a unit called 11 Path. It's a civil unit from Telefónica. This is our first talk in English, so be patient with us. Yeah? Or drink something. I don't know. It's the same for me. Yeah. This talk is about the Bicho. Yes, the Bicho is a hardware backdoor, and we also construct and software to do this backdoor functionality better. Yes, so to start talking about this, we have to talk about why we are working about backdooring a canvas. Yes. And the real question is why not? Is why we can we can backdoor our computer, we can modify our computer, our server, our phones, and why not we can do the same with our car? Yes, and just we are curiously people like you, like all of you. So the real reason is because we can. This is the project. So the first thing that we need to talk with you is about safety, because car hacking is not the same like computer hacking, because it's dangerous. You can modify something in the CAN message that can activate the brake or the gas pedal or just some function in the engine, and you can break something, or you can you could cause injury in someone. So you have to be careful. Thank you. Careful. Gracias a todos los españoles. You have to be careful with this, because there is not so important how trained are you, because accidents occur. Yeah. So you can see that in this sample, for example. Okay. He is worried about safety. Huh? Okay, when we talk about car hacking, most of you think about the connector cars, the model cars, yeah? Because in the model cars that we can find in our country, yeah? Okay, it's not working. Yeah. You have a lot of thing of connectivity. For example, you have the TPM. Fine. Yeah, that's true. It's my car. No. In the connected car, you have GPS, you have Bluetooth, you have Wi-Fi, you have the TPM module for pressure. You have SIM cards to control your car. You have a lot of interface to do something with the car, even USB or some storage, yeah, like SSID. So you have a lot of things to do or to play. But what happened with the canvas, with the network or the real network of your car? We want to work with this type of network because in our country it's not so common find this type of car. Okay, this type of car, see, with all this thing, yeah, it's not so common. So we want to play with this and find one way to access the network of the car and to control it remotely. Yeah, this is the project that we work. So for most of you, maybe Canvas is not so common. So we need to do a quick review about how Canvas work. This talk is not about Canvas, so it's just a quick review. The Canvas or the controller area network is all standard, yes, it's an old standard than about 13 years. Yeah, and so in that moment, security was an issue. So that Canvas was designed to work in some environment with a lot of noise, with a lot of yes, and noise is the correct word because you have an engine, and so you have a lot of noise in the interface itself. So Canvas was designed to be faster, to be efficiently, but not secure. Yeah. In that moment, all networks with Canvas was not only for cars. You can find some network with Canvas or with CAN protocol in industrial environment. Yeah, in like the people before here. But when we talk about Canvas, we have to for a car we have to talk about an standard from 1996 that was the introduction of this connector in our cars. Yes, this connector is the ODB2 ports. It's not very clear, but it's a connector that. This connector you can find in your car, in the cabin of your car, and is used to diagnostic or for diagnostic purpose. And this standard that was included in that date, you have a lot of pins that every manufacturer in your car can decide for what they will be using. Yeah. There is some specific pins like signal grounding or CAN high and CAN low that are standards, but you have a lot of things, a lot of pins that you can use or not if it's decided for the manufacturer. Yes.
Okay, this is the war part, and it's difficult, but it's necessary to understand. I hope super right. Okay, when we're talking about CAN, we have to talking about CAN bus. That's why CAN network is based on a bus topology. Each node could be a sensor or a vehicle EQ, and the information transmitted on the bus can be used by several nodes at the same time. CAN was developed for use in automotive environments where there is a lot of noise. It uses a system known as differential voltage, and that allows it to gain immunity against interference. Yeah. In this system, there is a transmitter that transmits a signal in duplicate, one with positive value and the other one with negative value. These are CAN high and CAN low signals. Yeah? If the receiver receives two signals that are not equal, it discards it, assuming that it's noise on the bus. Yeah? Moreover, CAN protocol has something known as inverted logic, where we have a dominant state, which is 0, and a recessive state, which is 1. So it influences a bit in the frame format. In that graph, we can see a standard CAN frame. The green part is the arbitration fields that contains the frame's ID. And one important thing here is that those IDs with mostly zeros will have higher priority on the bus. So that's why CAN frames associated with the engine has the lowest ID, so the higher priority on the CAN bus. Yeah? And after that, we have the data length in yellow and the data itself in red that can contain a maximum of 8 bytes. And as we can observe, there aren't source or destination addresses, neither source or destination ports like protocols we know better, such as TCP/IP. So a CAN node has to check the arbitration fields to know if it should take the frames data. Yep. I guess my English is not good enough to explain this clearly, so you can go to Wikipedia as well. Okay, this is how a CAN frame looks like. We have to know that a CAN frame does not indicate anywhere what kind of information is carried. For example, a CAN frame that is carrying information about RPM does not indicate anywhere that its information is about RPM. So that's why to find out what kind of information each frame is carrying, we have to do a reversing process. Yep. For that, there is a lot of different tools. This is an oscilloscope, and it's the lowest level tool we can find to analyze CAN signals.
Don't use it.
Don't use it, yeah. In our case, we had a CAN module that allows us to see the hexadecimal representation of such signals. Yeah, but yes, it's too fast to see. You know. It's impossible. On the other hand, we have the higher level tools that allow us to see CAN frames in a nice way, and we can analyze them so much in an easy way. Yeah. Anyway, it's still too hard. So
we have an example here. We are doing in a BW Fox. Yeah. We just start the light, and this is what's occurring in the sniffer. Yeah. So if you see it is again. Okay. Just you can see that the only action that I do is start the light, is put the light in on. Yeah. But there is a lot of frames of the data traveling in the canvas. That is why it's very difficult to do this one, because in your house, when you put in on the light, it's just one command. You put in on and the light is on. That's all. There is no magic. But in the car, when you activate the light in your car, the canvas is the module. I'm sorry, for the light is sending every time. Every second, a lot of frames send with the message lights on, lights on, lights on, lights on, lights on. Yeah, not just once. Yeah, so when you activate this one, you can see, for my horrible explanation, that there is a line with one change every time, but it's not the case, because when you activate the light in your car, you have that message constantly, but you have another message. Why? Because when you start the light in your car, not only the light the car is on, because you have the activation of the panel of the instrument, where you have the icon of the light, and you have other lights in your panel that putting on, and maybe other function depending of the car. So in this car that is an old, okay, it's an old car, and it's a mechanical action. We have a lot of message, but think about what happened with a new car. For example, an Honda Civic and Honda Civic from this year. We have a video about what happened when you put the key in the ignition mode. It's the fucking Matrix. Yeah. So, the real question is this one.
How we can find the CAN frame we want? It's a bit difficult. So, nowadays there are several tools to analyze CAN bus. Here in the car hacking village or in the vendors area, we can find some of them. CAN Spike, CAN Loop, CAN Tag, CAN Analyzer from microchip, or even we can use Socket CAN with open hardware tool as well.
With the CAN util for Linux, yeah?
Yeah, it's true. In our case, we began using car loop and car analyzer from microchip. Usually, these tools allow us to injecting car frames on the bus as well. But the frequency with which this tool makes the transmissions may not be fast enough to canvas. Yeah, that's when that happens. So, yeah, as he said, each node is saying currently its current state, so constantly its current state. So in this case, the light module is saying that the lights are off, while we are injecting every 100 milliseconds that the lights are on. So this is what produces the flicker effect.
So you can see that we need more speed to inject that payload. So with software, it's not so easy. So we build our backdoor to do this with the ODB2 ports. So that is why we start working in that project, and we present this one in the co-party the last year. And for this moment, for this project, a lot of people ask us about how it is possible to someone put in your car a backdoor, a hardware backdoor, and you don't notice that. Yeah. The answer is easy, because if you, for example, left your car in a car wash, it's a good opportunity for someone to put something in your ODB2 ports, or maybe in a valet parking. There are moments when you left your car and someone can do that. Or maybe if you give a ride some spy, maybe. Or maybe if you are married with James Bond, I don't know. Yeah? There's a possibility that we start working in that project that was the first one.
Yeah. When we began, we started with a simple injector. And there are a PIC 18F2680, yeah, with a transceiver to convert high and low signals. And the firmware that we developed in assembly can inject with a great speed on the car frame, so avoiding that what we saw in the previous video. And after came the malicious ideas, and we thought how we could control this remotely. So we added a SIM 800L, so that to control the hardware backdoor through SMS commands. Yeah, and that was the result. Our first proof of concept worked fine. And after that, we thought that would be nice to setting up the cam frames and the attacks commands through a PC software, so avoiding hard coding the cam frames and the commands into the firmware. So we added a USB interface. We have to develop a new hardware, where there is two modes, hack mode and a programming mode. We can toggle between two modes via this switch. Yeah, you have the programming mode and the hack mode. Yeah. And the new hardware has it looks a bit nice. Just you use SMD components. Yeah.
Is this one?
Yeah, it's this one. Yeah. Here we can see it's the comparison with a rubber ducky. You can see it's little hardware. Yeah.
So we have it at this moment. Let me see. At this moment, we think about it was a nice project, but we need to improve it. Why? Because to configure this one, how, like Sheila said, we need to know about assembler. Yeah, you have to put out the microchip, program it, and put it again. So we start working in this new interface and this new design, and we need, or we want to create another piece of this project that was software. Yeah. So this is the real thing about the car backdoor maker. So for us, this is the Bicho, yeah? And this is the car backdoor maker. Why? Because in this program, you don't need to know anything about assembler, anything about programming. Just you know to need the correct frame that you want to inject. Yeah? Put it right in the memory, and it's all. So this is the other part of this project. When we start creating this, we work in this setup, in this basic setup, when you can see the ID, the identificator. I think that Sheila told you, but when the ID is lower, there is higher
priority on the bus.
Higher priority in the bus. So because the lowest ID is the engine function, yeah. This is the length of the frame, and these are the data in the 8 bytes. This is the first part, and we have the SMS control. So when we create this one, if you read a message, a frame message from the cam that start the light, you can put that correct frame here. You can say with SMS you will control it, yeah, and just press right, and that's all. But when we construct this, when we build this application, we start thinking about another function, yeah? And we start working in the advanced setups. The first thing is in the possibility to introduce your phone number. So if you put this one in your car, and you put here your phone number, so only you can control this Bicho, yeah, and anyone's can. And the second thing is to run automatically this payload. How? For example, if you in your car you are driving your car and throw for a specific location with a GPS, I can tell to the program, to the Bicho, that start automatically the payload, for example, for activating the brakes, or for starting the light, or for controlling the fuel, or everything. Yeah, and the same we work the same with a specific frame. So if you are driving your car and you, for example, start the light, I can tell you to the Bicho that when you start the light, the car stop, yeah? The engine stop, yeah? Or the brake stop, I don't know. But if you want to see this one, podemos verlo aquí. En español lo digo. Estoy sufriendo como un condenado. Okay. Muchos años que no sufría tanto en una charla. Me mandó a mí.
Keep calm. Creo que fui yo, pero bueno.
For example, this is the Bicho in the programming mode. Yeah, with this deep switch down, it's in programming mode. You can see that we have a green light.
Yeah, green.
Yeah? Mm-hmm. But if I start the program, la gente de seguridad.
La seguridad pesa.
If I start the program, and I just put the connect button,
yeah.
This light is red now. Yeah. So this is telling me that there is a communication between the software and the hardware. Yeah. So if I know the correct frame, I just put it here. And the correct SMS that I want to use to control this one. which 4 letter can I use? Which I want. So I can use 4 letter in upper case. That's all. For example, and it's okay. Yeah. Here I can tell my phone number. And if I press right, that's all. The module is ready to hack. Yeah. So I just disconnect this here, put this one, put this in up to hacking mode, and connect this in the ODB too. That's all. Yeah. They are friends. Thank you.
El video, ahora.
No,
Bueno.
So, but at this point we have. Sorry. But at this point we have another problem, that because to do this one, we need to know the correct frame. So we have another problem. Yeah, I have to sniff my car every time. But I have another problem, that my car, for example, have a specific message can I give to control the light, the brakes, the speed, everything. And your car, I'm sure, use another CAN message, yeah, because it's not standard, that message. Every manufacturer has implemented his own CAN message. Even in the same manufacturer, every model has different CAN frames. So we start working in another thing, that is an open CAN database. Yeah, and an open CAN database is a shared database just to share information about the CAN message. If you read with some sniffer a CAN message for your car, you can come here, put add CAN frame, and that's all. Yeah, complete this information. So if you don't find your car, you can add a new car, and if you don't have the vector, you can add a new vector, and it's totally open and free for you. Yeah, too. So at this moment we have a hardware, we have a software, and an open CAN database. So you have a lot of fun. Yes, and everything is free. Yeah, that's the beautiful of this one. And you can see an example of this one with this video. We send a message with light on, and now a message with stop the light, and the light is off. Thank you. Sí, el enano era. If you are thinking that that's all, the correct answer is yes. It is. It is for now. For now. Yeah? This project is not over. Yeah? So to finish this, I want to thank some people that support us, for Nicoleño for our English. Yeah, it's his fault. Yeah? Eva y Chris for the design of the web page, del código K for the design either, Mondalan for his support with sharing Canvas for the database. Yeah, that's all. So thank you very much, and if you have questions, we are here. ¿En español?
Si es en inglés, no.
I'm not familiar with cars, generally. Where is it located? Is it easily visible if my car was hacked?
Yeah.
The OBD2 port is really exposed. It's below the steering wheel.
Below the steering or below the... ¿Cómo te lo digo? ¿En el volante o en la guantera? It's in the cabin. Yeah, please.
By the US on the connector is to the left of the steering column. Go down under. eBay sells key locks.
Yeah.
Sensor. So if you're concerned about it, you buy the key lock, you put it on.
Mm-hmm. Yeah, nice. Right.
Thank you very much.
That's where the fuses are, right?
Not that far down, because by law you have to be able to have, as a driver of a car, connect it in, without putting your head between your knees and your left foot in the passenger side.
Yeah.
Thank you.
Thank you.
Any other question? Te odio.
You can't.
How long did it take for you to develop all this?
How long?
How long?
10 meses?
A year?
I don't know. 10 months? I don't know. Yeah.
Yeah, 2 months.
Yeah.
It's our hobby, so it's not work. So.
Yeah. I think all the project was not easy, but I think that it's difficult to find the correct frame. This is a very complicated work.
Yeah, we had a lot of reversing processes to find the cam frame you want for the lights, for the engine, or whatever. So it take a lot of time.
That's because we do the open database. Yeah.
Yeah.
This is to share.
Yeah. So.
Yes.
With cellular carriers, is it specific cellular carriers when you plug in your phone number? So
No.
Okay.
You can put anyone. It's not a problem.
That is GSM. GSM.
The GSM is for locating with the provider, yeah, but it's not important the size of the chip, yeah.
Yeah. This is.
I say this because in the States they have GSM and they have CDMA.
Okay. No, it's GSM. Yeah. Yeah. I'm sorry. Yeah.
T-Mobile.
So, any other question?
Okay.
No.
Thank you very much.
Thank you very much.
And